Welcome to Shift Testing Left to Build in Quality. Hello, I'm Ken Pugh. First, let's start off where what are the tests for this session? Well, they're also known as objectives. You should go into a session and have tests and see whether those tests pass by the end of the session. So let's look at some objectives. Describe how shift left testing helps build in quality. Identify how loopbacks are reduced by shift left testing. Identify the different aspects of shift left testing. And describe the collaboration in shift left testing. Do you have any tests? If so, put them in the chat box and we'll see whether we've met them by the end of this session. So hello, again, I'm Ken Pugh. I'm the Chief Consultant at Ken Pugh, Inc. I'm the author of 7 books, including Lean Agile Acceptance Test Driven Development, Better Software Through Collaboration, as well as Pre-Factoring, Extreme Abstraction, Extreme Separation, and Extreme Readability. And I'm the co-creator of the Safe Agile Software Engineering. Here's my overall rule. There are exceptions to every statement except this one. And what do I mean by that? If I say you always ought to do something, I don't mean always, but usually always. And when I say you never ought to do something, I don't mean never ever, but usually never. So if you find something in this session, you go, that won't work here, feel free to raise your hand with the exception, because we learn by the exceptions as well as by the rules. Here's my second overall rule. Context is everything. Everything exists in a context. And everything is always true in some context. You've probably read of Netflix doing 15,000 deployments a day. But as a user of Netflix, what's the worst thing that can happen? Your video doesn't show up, so you just reload it again. You're saying, it must be my internet provider. But if you're doing stock market transactions and you get one of those wrong, well, you've got an unhappy customer and a Securities and Exchange Commission to answer to. And finally, perspective. If we only look at one thing, one way, we get a distorted view of the underlying truth. So it's best to have a second and a third perspective. And now we get 3 views on the same underlying truth. And we have better knowledge and better understanding. So that's the power of 3. So first, a brief introduction. What is built-in quality? Well, it's building the right thing and building that thing right. 2 sides to it. So why do we want to invest in shifting left? Well, here's a curve of the relative effort in solving an issue at particular stages in the deployment cycle. If we find an issue at requirements time, while we're gathering the requirements, we're going to call that a 1. If we don't find out about that issue until coding time, it's a 4, because now we have to have another meeting, redo a little bit of code. If we don't find out about it until testing, that's a 16, because now we have to put a defect, triage it, have a meeting on it and everything. And finally, if we don't discover it until production, it could be a 64. Now, some places have actually done some measurements, and it doesn't matter really whether you're waterfall or agile. This was an agile place, and they realized that still it was like 250 times the effort of fixing an issue in production rather than fixing it at requirement time. Now, could be something else. So let's see what happens here. And typically, we write a feature, then we write a story, then we write some code. And this is the old style, if you will. And then you realize, well, I've got some code, I better write a test for that code. And then you realize, well, the story is done, I'd better figure out how to test the story. And finally, it's like, well, we've got a feature done, let's figure out how to test the feature. And this is what we call the old-fashioned traditional testing V model. Okay. We write stuff and then we figure out how to test it. And what happens with our flow in this model? Well, we decide we're going to do something. We analyze that requirement, be it as either a simple story or something larger. We do a little design, some code, some test, deploy it, and finally execute it in production. And we get a flow. And that flows our business value from decision out to execution. If it was only that simple. So what happens is we get loopbacks. We get loopbacks from test to code as those defects pile up in our JIRA board. And that breaks our flow. And then we get loopbacks from test to analyze because we realize that we didn't really understand the requirement. And finally, there are some loopbacks from execute back to analyze as well. And every one of these breaks the flow, the delivery of business value. Now, in test first, what are we all doing? We're always thinking about testing. We write a feature, we create the test for that feature. We write a story, we create a test for that story. We write the code, and we create a test for that code. And we're shifting that testing left. And in fact, as we'll see, we write the test before we write the code. We write the story test as we write the story, and same for the feature. So we're shifting our testing left. Now, is it shift testing left or shift left testing? Well, it really doesn't matter. You can't test something until you have that something, obviously. So what are we talking about? It's really about creating the test on the left, not executing it. Creating when we're coming up with our requirements. And here's our overall phrase. No code goes in until the test goes on. We're not going to start an implementation until we have a test that tells us that that implementation matches the requirements. So let's take a look at the flow here. Decide, analyze, test, code, and so forth. We have three different processes that are going on. The first is hypothesis-driven development. And that's what the product manager and the owner get together and do. And the cycle for it is at the time you're going to decide to do something, you create a hypothesis, a test for it. And we'll be doing the testing in production. And we'll see that in a little more detail. Next, we have behavior-driven development. And that's the triad. The product owner, customer, business analyst, the developers, and the testers. And that goes on between the analysis of the requirement and late as staging. And then we have TDD, or test-driven development, or test-driven design. And that's the developer, or a pair of developers, or a developer and tester. And that's much tighter. In the design and coding phase, very quick cycle time. So those are three things we're going to talk about. HDDD, BDD, and TDD. Now the key is we want to write testable features, story, and code. So at the top level, we're going to have some feature tests that we'll create with hypothesis-driven development. At the next level, the story test we'll create with behavior-driven development. And our code test we'll create with test-driven development and design. So at the time we are creating our features, stories, and code, we are writing these tests. There's another way of looking at how these things interrelate. We have our as-is system. And our as-is system has some story tests from the outside and code tests for the inside components. And then in addition, we might have some enabler tests, the architectural tests that go against our infrastructure or our architecture. So that's where we would be as an as-is system. Now we come up with an idea for a new feature, and that's going to be our to-be system. And we'll have some feature tests, the hypothesis-driven development, and we'll look at that shortly. And then again, we'll have some story tests for the feature itself, or the individual pieces, and some code tests for the implementation. And of course, these will be our new, and we'll also should still be able to pass all the old story and code tests as well. So it turns out that tests and requirements are related. Every requirement should have a test. Every test is a requirement. And if you cannot deploy with a failing test, then that test is a requirement the system must meet. Requirements have tests. Every test is a requirement. And obviously, we want our requirements before implementation. That is the number one thing that people say. Well, if we need requirements before implementation, then tests and requirements are completely interrelated. Now, there's a little ditty that goes something like this. Tests and requirements, go together like a horse and carriage. How they go together. You can't have one without the other. This is why I'm still in software. So let's look at the top. Here's hypothesis-driven development. In hypothesis-driven development, we have an idea for a functional change, a new feature. And we're going to create an hypothesis as to whether the customer is actually going to use that functionality. And that is a test of whether we're building the right thing. If the customer doesn't use it, we're building the wrong thing. So this is from Lean Startup, Lean UX, and some other places. We start with what we call a minimum marketable feature. And that's the smallest piece of functionality with intrinsic business or market value. And we want small marketable features, so we release our functionality sooner, get it out of production, and get our learning back from the users. So we need a benefit hypothesis for this MMF. Hey, we have the hypothesis. We build an MMF, the smallest piece of functionality. And then we run our test. Here is the creation of the test. Here is the execution of the test. And we evaluate whether that feature was actually utilized by customers. Maybe it isn't, in which case we just stop work on that feature. Maybe he said, yep, it looks good. Let's go on to our next MMF. Or perhaps we go, I'm not sure that we got it quite right, so let's do a pivot. Let's change the MMF slightly and send it out again and see if we get a better result. So that what we're doing is to learn what users truly desire based on their behavior. So let's give an idea here. A cruise control with speed automatically set by the speed limit. And we're going to find that speed limit either with a GPS and a map that has the speed limits, or maybe a sign reader, or maybe both. A couple of ways we could do this. Now it turns out autonomous vehicles are going to require this, because if an autonomous vehicle keeps speeding, then Elon Musk is going to have a lot of speeding tickets to pay. So there's our idea. And let's give a little more detail here. Given a speed limit sign, when the car views it, then the speed is set to 35 miles per hour. There we go. That's the idea. And now what we need, a benefit hypothesis with some metrics. And the template for this is we think that a capability will produce an outcome as measured by a metric. And here's the example. We think that cruise control with speed limit finder will be used by drivers 90% of the time as measured by telemetry. And we're going to keep track of how often the cruise control button is pushed. There we have a test and a way to measure that test, which obviously we can't do until it's actually in the car and under use. So what do you think the results will be? How many people do you think will actually utilize this? Enter into your chat box what you think. Now, here is where context's important. Perhaps we're in a country where they've got speed limit cameras all over the place. And it costs a lot of money if you exceed the speed limit. Chances are drivers might be using this 95% of the time, if not 100% of the time. But maybe if you're in a lax place, like maybe Boston, well, maybe they won't use it. So we'd have to do a pivot. Maybe we're going to pivot and say, we're going to also allow you to set the speed limit by some amount over. And now the driver's doing this, so if the car speeds, Elon Musk won't have to pay the ticket. So what should we have as a limit of how much you can set it over? 5, 10, 15, 20 miles per hour. Well, maybe you might stop there. And then if it turns out you go to a place like Boston, Massachusetts, where I lived for a while, 20 miles per hour, it would be the minimum that you'd want to be able to set it over the speed limit, or else you get tailgated by all the other cars. So maybe you do a slightly different pivot. Maybe we just display the speed limit and make the driver feel guilty. Or display a warning if over the speed limit. So we take an hypothesis, we see what the results are, we either decide to drop it, move on to the next one, or pivot and change our MMF accordingly. So that's hypothesis-driven development. Let's take behavior-driven development. Tests are created for the functionality prior to its implementation to ensure we're building the thing right. And it's done by the triad, the developer, tester, and customer. Customer is the product owner, the business analyst, the SME, anyone who knows what the requirements are. And the triad combined are responsible for the quality of the product. And we're now again thinking tests first. And the other reason why we want to do this is it's easier to automate tests written before an implementation than afterwards. If you don't think about testing until the application is all done, the only way you typically can automate is through the user interface. And that's often slow and fragile. So in addition to just understanding, we also thinking tests first will help us with automation. So let's look at how these things happen. We have a behavior for a scenario. That is, we have some setup or given of a current state, and we have a trigger, which is often the when, some action or event that occurs, and then we assert that this is what we expect the result should be. That's a scenario of behavior. Well, what's a test for this scenario? Well, we need to set up that current state, we need to trigger the action or event, and then check that the actual results match our expected results. If they do, our implementation passes. If not, well, we still have work to do. So it turns out that BDD and ATDD are pretty well related. Behavior-driven development focuses on the behavior. That's scenario. Given the car speed is 30 miles per hour, when the speed limit changes to 20 miles per hour, then the car speed becomes 20 miles per hour. Pretty straightforward. And we're going to have a test that behavior. Here's our test. Given the car speed is 30, speed limit changes to 20, We check the car speed becomes 20 miles per hour. Behavior, test of the behavior. Well, it turns out acceptance test-driven development simply focuses that we are going to test that behavior. Behavior-driven development starts with the behavior, which gets turned into a test. So BDD and ATDD are actually just two slightly different viewpoints on the same underlying process. But the other reason we want to do these scenarios is, what else might we want to test when we change to 20 miles per hour? Maybe how quickly it slows down, or whether it jams on the brake when we want to make sure that that doesn't happen. Or maybe we want to make sure it does as a behavior. So we have a lot of other behaviors that we can specify ahead of time that then the implementers can make sure that the implementation passes. If you don't specify it, it's hard to write an implementation for a requirement that doesn't exist. So let's give a business rule scenario. Here is a school zone. Between these hours, that is what the speed limit should be. And we want to write some tests for this. Well, our speed limit varies in school zones, and so we're going to come up with some tests. Here's our business rule data, 7:45 to 8:45, it should be 35 miles per hour. And here are some tests for that business rule. At 7:44, it should be 45 miles per hour because that's the speed limit for the road. And at 7:45, it should be 35 miles per hour because that's when the school zone applies. Now, once again, once we come up with these tests, we can start to ask a few more details. Is it exactly 7:44? What about 7:44:01? Can I still be at 45 miles an hour? And so forth. And once again, how quickly do I need to slow down? And exactly where does that 45 or 35 mile per hour begin? Does it begin at the speed zone, at the speed limit sign, or somewhere else? So that's our business rule test. So the third part is test-driven development, or I also like to call it test-driven design. And we're once again thinking test first. We do not test code, we code to the test. An entirely different mindset shift. So, in test-driven design, our design allocates responsibilities for passing those external tests, the ones we got from behavior-driven development, to internal entities, our components, our classes, and so forth. That's test-driven design. So, we also have a test-driven development cycle, which consists of writing the test first, checking that the test fails to make sure that the test is actually testing something, writing the code to pass the test, checking that all the other tests still pass, now looking at our code and refactoring it if necessary to make it a little cleaner, and finally checking all the other tests pass. Well, now that BDD, we can't really test it until we have the entire implementation, but TDD, this cycle could be on the order of seconds or minutes, depending on how fast you write the test and how fast you write the code. It's a very quick cycle. Okay. So let's give an example of TDD. With BDD, we came up with our business rule and our test for that business rule for the school zone. So now we're going to take just one of those tests and we'll code it up. 7:44 at 45 miles per hour, because that's the speed limit for the road. Well, we'll make sure that our component returns that. And then we'll take the next test, 7:45 at 35 miles per hour. And the next test, 8:45 at 35, and so forth. 8:46 at 45. And we'll code one test, we'll write the code to pass it, make sure everything else passes it, and continually add and add more tests. And that's test-driven development. One little test at a time. Let's do another example of test-driven development, the speed side and processing? Well, we could start by just seeing if we can identify the speed limit on a sign that's head-on with very clean text. If we can do that, we might move on to the next scenario with a sign that's side-on. You're looking at it this way with clean text. Maybe a sign head-on with fuzzy text. Maybe a sign head-on with missing letters or holes in the sign or whatever. And we continually change our implementation to pass the additional scenarios and the tests for those scenarios. So this is not an ending, but a beginning. What have we shown here? Well, we've got our code test for the inside and our story test for the external test for the outside that we developed with BDD and TDD. And those feature tests, the hypothesis-driven development, are our customers using that actual feature? And then we have our story test and our code test for that new feature. Now what happens with our flow when we do this? Well, at our decision point, we are going to decide with tests. We are going to create that hypothesis that we are going to check in production. When we analyze our requirements, we're going to analyze those with tests to make sure that we have a clear understanding. When we design, we're going to design with tests to make our code testable. And obviously, when we code, we're going to code with tests. Oh, this next little section here, are we still going to have to do some tests? Yeah, but they're going to be greatly reduced because most of the functionality issues we've dealt with before. Maybe it's an environmental issue or some performance issue or something that is not testable on the developer's machine. Now, we're going to deploy, and we'll deploy with some of those BDD tests. And finally, we'll execute. And if possible, we'll execute with some production tests. That all depends on what your context is. So now, by adding all these tests, we're getting rid or dramatically decreasing that loop back from test back to code. And we're decreasing dramatically, in fact, in some places, actually getting rid of entirely that loop back from test to analyze. And often, that loop back from production to back goes away as well. And what does this do for us? It dramatically increases our flow. Now, just to recap here, we described how shift-left testing helps us build in quality. We identified how loopbacks are reduced by shift-left testing. We identified some aspects of shift-left testing. And we described the collaboration in shift-left testing. So we can also take a look at the chat and see if we've answered any of your tests. Did it pass your test? I'd just like to make one note: how to experience behavior-driven development, acceptance test-driven development, and test-driven development. I've got an online course for corporations and companies because we want to deal with the collaboration of the triad. And that's on lean, agile, acceptance test-driven, behavior-driven development, better software through collaboration. And that involves the triad: the product owner, the developers, and the testers. And during this workshop, we use the team's real stories for the exercises. And we have 2 half days for all the teams and a half day for each team, so we can delve into the issues that are particular to that team's context. And we have behavior-focused test-driven development and design. And that's 5 half days, breakout sessions for the pairs, and that's either 2 developers or a developer and a tester. If you want more information, contact me on LinkedIn at Ken Pugh. Email me, ken@kenpugh.com. Well, thanks very much.